Hello, it's Dr. Newmaster back again to help you with this question. What is a forest? I remember back near Cambridge where I grew up, there's a big woodlot behind my house. And when I was 8 years old, I grabbed a field guide and started crawling around in the woods. And that's literally what you have to do, is start wandering around and get this experience, looking around in a forest. It's not an easy question to find what is a woodlot, but I want to give you some guidance and some things to think about. Now for me, it's been 20 years of research of wandering around woods in North America, South America, in Taiwan, different places, trying to understand forest dynamics and the ages of different forests and the species diversity that you find within. One thing I want to start to point out is forest structure. When you look around a forest, there's trees obviously, and there's structure. There's different species of trees, and there's different layers. We start off with a canopy that's high, and the dominant canopy that sticks out above all the other trees. These are our super canopy. In the tropics, these trees can be 100 meters tall. Here we're looking at trees that are probably 30 meters tall. And the maples are sticking out and the pines. And then we have a sub-canopy, and below that we have a couple different layers. There can be shrub layers, like this layer over here, which is quite heavy with shrubs. And this would have a shrub physiognomy. Physiognomy is a word that we use to talk about structure. On this side of me, not very many feet away, is an open area below. There's not many shrubs at all. And when you look at the forest floor, you would think, well, there's not a lot of diversity in this forest, in this woodlot. But then again, maybe you need to go and look down. Let's take a look and see what's on the ground. We start pushing across some leaves, we see moss growing on the ground. And if we look more closely at some of these, we can see that they have these little capsules. Maybe you've seen these before. This is Polea nutans. It has coppery capsules, setae on it, the stalk, and then the capsules above. And at this time of year, these capsules will swell up, the cap will burst off, which is the operculum, and spores will be dispersed. Wind dispersed and gastropod dispersed. There's another species here, Physidens, as well. If you put a piece of cardboard down on the ground, and you came back to check it in the morning, turned it over, you'd see a lot of species of gastropods. These are slugs and snails, and they live in about a foot of soil just below the surface. One thing we haven't talked about so far, we talked about forest structure, we talked about species diversity, the different types of canopy that you would see, but we haven't talked about process. Here on the forest floor, when we look around, we see apparent material. This is some kind of loamy silt that's found here on the ground. There's not a lot of organic layer. Back when settlers first came in and started to bring plants with them, they also brought some soil. They also brought earthworms. And earthworms aren't native to this area. The earthworms come into the forest and they eat all the leaves and all the debris, and we have very little organic layer left in the Great Lakes forest, mainly because of earthworms. The nutrients in the soil come from various places. And this is part of nutrient process. This is one of the processes of forest. This is one of the things that defines a forest. It's not just a bunch of trees living together, but there's all these interconnections. So nutrient fallout comes through the leaves. They leak out, exudate from the carbohydrates from photosynthesis. It runs down the trees. It runs through lichens. And there's all types of nutrients that come out of the lichens as well, into the soil and start to plenish the soil with all types of nutrients. The plants themselves and the roots that are below the ground are also connected with fungi. We have mycorrhizal fungi. And the mycorrhizal fungi are experts in breaking down the debris that we see. And if it wasn't for the fungi, all this debris would literally pile up in the forest. Not just debris, but also the needles. And if we look at the pine needles that are sitting on the forest floor, they take about 8 years to decay. And that's with the help of fungi breaking them down. Fungi are connected to the plants. They share limited resources like nitrogen with the plants that we see growing. So small seedlings have a mycorrhizal network, and they start to share nutrients, carbohydrates to the fungi, and from the fungi to the plant, nitrogen, which is a limiting nutrient. Those are some of the things that make up a forest. There's many more for you to think about, like time. How old is a stand? How long did it take to grow? Spatial structure. How many of these types of forests are found in this part of the world? Lots of questions to answer.